Welcome to my YouTube channel. In the previous lecture of complex analysis, we have discussed about argument of a complex number z. Now we discuss in this lecture 4. So we have discussed that a number z equal to x plus I y can be written as in this form, this z, and this will be the vector, and we can write with arrow. So this can be written as this is x and this is y, and if this is theta, that is positive x-axis with this r in anti-clockwise direction theta, then we can write this r x equal to r cos theta in polar coordinate and y equal to r sin theta. So then z can be written as r cos theta plus I sin theta, and this can be written as r e to the power I theta. So z can be written as in this form. This is the form, and also here tan theta equal to y by x. Theta is the argument of this number z. So this is r e to the power I theta. If we have a result, if m is an integer, that is m is an integer, then we can write r e to the power I theta to the power m equal to r to the power m e to the power I m theta. That is r to the power m cos m theta plus I sin m theta. So this is a theorem. So from this we can write this. This is a De Moivre's theorem. If m is an integer, then we can write that cos theta plus I sin theta to the power m equal to cos m theta plus I sin m theta. You can note now we discuss function in complex numbers. So let us consider a and b to set subset of C. So this is a and this is b. So a function f from a to b is a rule in which for every z0 equal to x0 plus iy0, there exists a unique image w0 equal to u0 plus I v0 in b. So a function, this is z0 and this is w0. So f of z, this is w equal to f of z, is a function, that is a rule in which for every z0 equal to x0 plus iy0 from a, there exists a unique image w0, that is u0 plus iv0 in b. So this is connected with this by this rule. So this is a function. So here this is xy. So this will be x0 0 plus iy0. If this is a point x0 y0 in this region, then it is connected in this uv plane with u0 plus iv0, it is w0 by this of z. This is the graphical representation of function w equal to f of z equal to u plus iv. So here this is the real fz and v is imaginary fz. So it can be written as real f and this is imaginary f. As this is uv is a function of uxy and uz and vz is a function of vxy. So in this place, so if we take a as a subset of R2, then this u is a function from a to r and v is also a to r. So this function is a real value function, and as this is a subset of from this, as c is a function from this xy, so xy from R2. So now we can take this a as a subset of C. This will be, now this will be w equal to f of z and can be written as a real f plus I into imaginary f. So you can write in this form. Real f and imaginary f completely identify the function fz. Also, this function f of z equal to u xy plus I v xy can be written in polar. In polar form, this can be written as u r theta plus I v r theta. So you can write in this form. Now we discuss limit. Limit is similar in the function of two variables also in real analysis. So limit are same, but here this limit z tends to z0, f of z equal to L means that for any given epsilon greater than 0, there exists delta which is depend on epsilon and z0, greater than 0 such that modulus fz minus L less than epsilon for every z belongs to D, where f is defined on D from this and D closer. So z belongs to D closer. These are the properties. So for every z belongs to D and 0 less than z minus z0 less than delta. So this is the definition of limit. So this means whenever z is near z0, the value of fz near to L. So this is the definition of limit. Let fz equal to uz plus I vz and b defined on D except possibly at z0. So here where this uz equal to uxy and vxy are real value functions. These are real value functions. Then limit z tends to z0 f of z equals to L plus I L dash if and only limit xy goes to x0 y0 uxy equal to L and limit xy goes to x0 y0 vxy equal to L dash. Here fz equal to uz vz and uz is this and z equal to z0, that is x0 plus I y0, z0 equal to this and z equal to x plus I y. So z belongs approaches to z0 means x approaches to x0 and y approaches to y0. As limit z tends to z0, if z equal to this, it will happen if and only limit of this function at x y tends to x0 y0 equal to L and limit v xy as xy tends to x0 y0 equal to L dash. If this u goes to L and v goes to L dash, then hz goes to L plus IL dash. As xy tends to x0 y0, that is z tends to z0. So this is the result. And also if f z and gz are defined in a deleted neighborhood of z0, that is equal to x0 plus I y0. Deleted neighborhood means if this is z0, so with this, so except this point in this region fz and gz are defined. So these are defined. Let us consider this. And if limit z tends to z0 f of z equal to L and limit z tends to z0 vz equal to L, then we get result number 1, limit z tends to z0 fz plus vz equal to L plus M, that is this and this. And second, limit z tends to z0 fz into cz equal to L into M, and this also limit fz divided by cz z tends to z0 equal to L by M if zz not equal to 0. These are three important results. So if this individually fz goes to L, gz goes to M and z goes to z0, then sum will goes to this sum, minus goes to minus, and multiplication goes to multiplication, and division goes to L by M if gz not equal to 0, that is M not equal to 0. So now we consider an example and we discuss the existence of limit for a complex function. Let us take an example. Fz equal to z bar divided by z. So we discuss limit as z tends to 0 f of z. Is it exist or not? So we will discuss. So from this we get fz equal to z bar multiplied by z bar, and this is z into z bar. So this from this we get z bar whole square divided by z whole square. So from this we get x square minus y square minus 2i xy divided by x square plus y square. So you can find from here we get x square minus y square by x square plus y square minus I and 2 xy divided by x square plus y square. So from this we get uxy equal to this, that is x square minus y square and x square plus y square, and vxy equal to minus 2xy divided by x square plus y square. Now if this ultimately goes to L and L dash, then we say that this function complex function goes to L plus I L dash. So first we show uxy as z tends to 0, that is xy tends to to 0, xy tends to 0, 0, this limit of u and v exist or not. So for that, z equal to z bar divided by z. So for this we take y equal to mx. So this limit goes to limit x tends to 0, and for this x square minus m square x square divided by x square plus y square, that is m square x square. So from this x square common, 1 minus m square. From this we get 1 plus m square. Depend on m, and similarly from this x tends to 0 and this goes to minus 2 x into mx divided by x square common, 1 plus m square. So this goes to minus x square, that is 2m minus 2m divided by 1 plus m square. This is also depend on m. So as xy tends to 0, 0, limit u and limit v does not exist, as both are depends on m. So u and v does not exist. This implies that limit z tends to 0, fz, that is z bar divided by z, does not exist. So this is very important question for the students of IIIT Bhagalpur. This is the previous year question of IIIT Bhagalpur for the paper MA 201. So if you are engineering student of IIIT Bhagalpur, this question is very important for you, and also this lectures complex analysis, it will help you very much. I will cover all the previous year questions and the whole module. If you like it, please subscribe my channel and share with your friends. It will help you very much. Thank you very much.